A chemical equation is the symbolic representation of a chemical reaction in the form of symbols and formulae, wherein the reactant entities are given on the left-hand side and the product entities on the right-hand side. The coefficients next to the symbols and formulae of entities are the absolute values of the stoichiometric numbers. The first chemical equation was diagrammed by Jean Bégin in 1615. Form. A chemical equation consists of the chemical formulas of the reactants and the chemical formula of the products. The two are separated by an arrow symbol, and each individual substance's chemical formula is separated from others by a plus sign. As an example, the equation for the reaction of hydrochloric acid with sodium can be denoted 2 hydrogen chloride plus 2 Na2NaCl plus H2. This equation would be read as 2 hydrogen chloride plus 2 Na yields 2 NaCl and H2, but for equations involving complex chemicals, rather than reading the letter and its subscript, the chemical formulas are read using IUPAC nomenclature. Using IUPAC nomenclature, this equation would be read as hydrochloric acid plus sodium yields sodium chloride and hydrogen gas. This equation indicates that sodium and hydrogen chloride react to form NaCl and H2. It also indicates that 2 sodium molecules are required for every 2 hydrochloric acid molecules, and the reaction will form 2 sodium chloride molecules and 1 diatomic molecule of hydrogen gas molecule for every 2 hydrochloric acid and 2 sodium molecules that react. The stoichiometric coefficients result from the law of conservation of mass and the law of conservation of charge. Common symbols. Symbols are used to differentiate between different types of reactions. To denote the type of reaction, symbol is used to denote a stoichiometric relation. Symbol is used to denote a net forward reaction. Symbol is used to denote a reaction in both directions. Symbol is used to denote an equilibrium. The physical state of chemicals is also very commonly stated in parentheses after the chemical symbol, especially for ionic reactions. When stating physical state, denotes a solid, denotes a liquid, denotes a gas, and denotes an aqueous solution. If the reaction requires energy, it is indicated above the arrow. A capital Greek letter delta is balanced. Looking at the next atom, the right-hand side has 2 atoms, while the left-hand side has 4. To balance the hydrogens, 2 goes in front of the H2O, which yields. It can be balanced by putting a 2 before O2, giving the balanced equation. CH4 plus 2O2 CO2 plus 2H2O. This equation does not have any coefficients in front of CH4 and CO2, since a coefficient of 1 is dropped. Ionic equations. An ionic equation is a chemical equation in which electrolytes are written as dissociated ions. Ionic equations are used for single and double displacement reactions that occur in aqueous solutions. For example, in the following precipitation reaction, CaCl2 plus 2AgNO3 California 2 plus 2AgCl, the full ionic equation is California 2 plus 2Cl minus plus 2Ag plus 2NO3 minus California 2 plus 2NO3 minus plus 2AgCl. In this reaction, the California 2 plus and the NO3 minus ions remain in solution and are not part of the reaction. That is, these ions are identical on both the reactant and product side of the chemical equation. Because such ions do not participate in the reaction, they are called spectator ions. A net ionic equation is the full ionic equation from which the spectator ions have been removed. The net ionic equation of the preceding reactions is 2Cl minus plus 2Ag plus 2AgCl, or, in reduced balanced form, Ag plus Cl minus AgCl in a neutralization or acid-base reaction. The net ionic equation will usually be H++ O minus H2O. There are a few acid-base reactions that produce a precipitate in addition to the water molecule shown above. An example is the reaction of barium hydroxide with phosphoric acid, which produces not only water but also the insoluble salt barium phosphate. In this reaction, there are no spectator ions, so the net ionic equation is the same as the full ionic equation. 3 bar 2 plus 2H3PO4 6H2O plus bar 32 3 bar 2 plus 6O minus 6H plus 2PO 43 minus 6H2O plus bar 32. Double displacement reactions that feature a carbonate reacting with an acid have the net ionic equation 2H plus CO32 minus H2O plus CO2. If every ion is a spectator ion, then there was no reaction, and the net ionic equation is null.